A vessel, a vessel contains n molecules of an ideal gas. Dividing mentally the vessel into two halves A and B, find the probability that the half A contains n molecules. Consider the cases when n equals to 5 and small n equals to 0, 1, 2, 3, 4 and 5. From the binomial distribution of probability, Pn equals to factorial NCn into p to the power n into 1 minus p to the power n minus n, where NCn is the number of ways in which we can choose any n molecules from the total of n molecules, putting p equals to 1 by 2. Because the vessel's volume divided into two equal parts, we get Pn equals to factorial n divided by factorial n into factorial n minus n into 1 by 2 to the power n into under bracket 1 minus 1 by 2 to the power cap n minus small n equals to factorial cap n divided by factorial small n into under bracket cap n minus small n factorial to 1 by 2 to the power n. Answer. Now putting n equals to 5 and different values of n equals to 0, 1, 2, 3, 4, 5, we get different values of probabilities. When n equals to cap n equals to 5 and small n equal to 0, Pn equals to 1 by 32. When cap n equals to 5 n is equal to 1, Pn equals to 5 by 32. When cap n is equal to 5 n equals to 2, Pn equals to 10 by 32. When cap n equals to 5, small n equals to 3, Pn equals to 10 by 32. When cap n equals to 5 and small n equals to 4, Pn equals to 5 by 32. When cap n is equal to 5 and small n equal to 5, Pn equal to 1 by 32. A vessel of volume V0 contains n molecules of an ideal gas. Find the probability of n molecules getting into a certain separated part of the vessel of volume V. Examine in particular the vessel V equals to V0 by 2. Solution. The probability that volume contains 1 molecules is expressed as P equals to V by V0. Hence the probability that n molecules from the total n will land in V is expressed as Pnv equals to Ncn into p to the power n into 1 minus p to the power n minus n. The above equation is known as the binomial distribution of probability. From the above equation, Ncn equals to factorial n divided by factorial n into factorial n minus n. You know that the number of ways in which we can choose any n molecules from total number n. Hence the obtained result is Pnv equals to factorial n by factorial n into factorial n minus n into under bracket v by v0 to the power n into under bracket 1 minus v by v0. When v equals to v0 by 2 is taken, we have Pnv equals to factorial n divided by factorial n into factorial n minus n into 1 by 2 to the power n. An ideal gas is under standard conditions. Find the diameter of the sphere within whose volume the relative fluctuation of the number of molecules is equal to eta equals to 1.0 into 10 to the power minus 3. What is the average number of molecules inside such a sphere? Hence, relative fluctuation is defined as the number of molecules present in a fixed volume to the total volume of the specified region. Using this concept, we can calculate the diameter as d equals to under bracket 6 by pi n naught eta square to the whole power 1 by 3, where n naught equals to number of molecules per unit volume in a standard condition and known as Loschmidt's number. Similarly, average number of molecules average n equals to 1 by eta square. 1 mole of an ideal gas consisting of monoatomic molecules is enclosed in a vessel at temperature T0 equals to 300 Kelvin. How many times and in what way will the statistical weight of this system will vary if it is heated isochorically by delta T equals to 1 Kelvin? The statistical weight and entropy relationship is given by S equals to K log omicron, where S is equal to entropy and omicron equals to statistical weight. Now, first of all, we have to calculate the change in entropy. For we know that dS equals to dQ by T, where dQ equals to d plus dW equals to NCV dt plus 0, because in isochroic process dW equals to 0. Hence ds equals to dQ by T equals to NCV dt by T. Integrating S to S0 ds equals to NCV T0 to T0 plus delta T dt by T equals to NCV log T0 plus delta T by T0. This implies S0 minus S equals to NCV log 1 plus delta T by T. Equation 2. Now from equation 1, S0 minus S nu log omega minus K log omega naught equals to R log omicron by omicron naught. From we have NCV dt equals to IRT by 2 internal energy. This implies CV equals to IR by 2 IKNA by 2 for 1 mole. Hence from equation 2 and 3 we have K log omicron by omicron naught equals to IKNA by 2 log 1 plus delta T by T naught. Log omega by omega naught equals to log 1 plus delta by T naught to the power INA by 2, where I degree of freedom. And the statistical weight increases, putting value omega by omega naught equals to, we get 10 to the power 1.13 into 10 to the power 21 answer.